Hello, everyone. We're going to go ahead and get started. Today we're going to talk about Dagger and Hilt. Just for a quick introduction, I'm going to go a little bit over my background and also include what I work on. So I work on Gmail, Chat, and Meet at Google. We use Dagger extensively in our application to do a bunch of different configuration for the different features that we have. We also use it to speed up development time. We use Hilt to actually simplify employee onboarding with Hilt, or with Dagger specifically. And it also lets us design features in isolation. We're pretty used to at Google that people tend to want to do APK teardowns of features while they're being worked on. So Hilt makes it really simple for us to work on things in isolation. And then, while we're building them and making sure that they're ready, we don't have to accidentally leak it to everybody else. Just a quick overview of what we're going to talk about today. So I'm going to talk a little bit about what is dependency injection. We're also going to go over some core Dagger concepts. I'm not going to go over everything with Dagger. I'm just going to go over the foundation. We're also going to talk about Hilt, which we're going to include some of the various different tools that it gives you to help simplify setting up Dagger. And so to start off, I think the most important question that I hear a lot from people is, what is dependency injection? And what does it actually do for me? And so I tried to, for this talk, try to figure out a way, what is the simplest way that I can explain this to people without writing out huge paragraphs that no one wants to read or understand. And so what I came up with was this, which is dependency injection is the process of making a class independent of its dependencies, which some people might read that and be like, okay. And then there's probably a lot of you that are like, that sounds like word salad. I have no idea what you're talking about. And so bear with me a minute. I'm going to actually show some real world examples that hopefully will actually make this make a little bit more sense. So you can imagine we might have an image cache. A lot of you probably have something like this in your application. The internals of the image cache don't matter for the purpose of this talk. I've just showed the constructor just to make things simple. Another thing to keep in mind is there's this network API that you also are going to see quite a few times. Internals also don't matter. The only thing that's important is that it's an interface and not a class. It's the only thing that you need to remember. And also to make sure that we're on the same page, there are two terms I'm going to use a lot, and I want to make sure that we're all on the same page. So the first term is injection. You're going to see this come up a lot. Injection is the action of providing all of the dependencies for a class. The other term you're going to hear me talk about a lot is binding. So a binding is usually the dependencies of a class. This is a term that Dagger uses a lot. You can have multiple bindings for a class. You could have 10. In this example, we only have one. That's the network API. And so a few things that come back to the original point of why is dependency injection useful is there's sort of two examples. So you can imagine for this cache, we want to make sure that we're not always hitting the network every time. Maybe we have an LRU cache inside of it so that sometimes we just return what's in memory. Well, if we were creating a new instance of this image cache every time we wanted to access it, or we weren't controlling access to this cache, that would defeat the purpose of having the LRU cache. So one of the things dependency injection libraries will help you out with is actually controlling the life cycle of the object, how long it stays around in memory, and making sure that you can control that there's only one instance of it for that life cycle. The second most common, I think the most important part of dependency injection is what I like to call code that's focused around plumbing things around. So you can imagine if we have a recycler view, let's say that we use our image cache in this home fragment and we load a bunch of images. So in that recycler view, you might pass the image cache down to your view holder. And the adapter doesn't need to know about this image cache, but you have to pass it to it because eventually the view holder needs it, right? And so this is kind of a pain and a lot of code to set up for something that this class doesn't need to care about, right? So with dependency injection, I can completely remove that from the class, right? Because the view holder is the one that cares about it, not the adapter. And so this goes back to my original quote that I had up here, which is about making something independent, right? So we just wanted the view holder factory. We don't want the image cache itself. So we're making the class independent of its dependencies. You're just injecting what you need. And And so the next thing this goes into is basically, what is Dagger? So Dagger is a dependency injection library that's really favored on Android because of its performance overhead that it has. It does everything at compile time, doesn't use reflection or anything like that, which you don't want to really do on mobile. The way that you set up Dagger oftentimes is through the use of these annotations. And so this is a little different than how most people might be used to interacting with a library. You actually basically use different annotations in Dagger to actually go and construct what you want Dagger to do. And so if you don't use these annotations, Dagger's not going to do anything for you, and it's not going to understand what it is you want to do. These are the most common type of annotations I use in Dagger. I just want to put that out there. There's a lot of annotations that you can actually use in Dagger. It's a fully featured library. Don't think this is all encompassing. These are the building blocks that I think most people really need when they start out. We'll spend some time on each of these, and I'll kind of talk about what it is they actually are for and try to break them down to be as simple as possible. So the first one we're going to start with is the @inject annotation. And so what @inject is actually doing is you're telling Dagger that, hey, I want you to provide this object for me. I want you to be able to inject it. And when that happens, Dagger will look at the object in two different ways depending on where you put this @inject annotation on the object. You can put it on the constructor, or you can put it on different fields in an object. So these are the two types of injection that you'll actually see with Dagger, which is constructor injection and field injection. So far, the example that I showed today with the image cache was just constructor injection. I haven't actually showed you field injection yet, so we'll start off with constructor injection since we've already seen a couple examples of it. So we'll go back to our image cache. You'll notice I passed the @inject annotation in front of the constructor. So that means each one of these bindings in the constructor need to be provided by Dagger. So Dagger's going to have to go out and figure out how to build these things and eventually provide them. If we refactor this class just a little bit, you wouldn't want to do this, but if you refactored this class to use field injection, it would look something like this. So you've noticed I moved everything out of the constructor, and I went and switched things over to a latent init property. So this is a little bit easier to see with Kotlin than it is with Java, but you can see that this value isn't provided when the object's created. That's why it's latent init. And so that's actually important, and it's one of the reasons that you generally prefer constructor injection over field injection, because when the object's created with constructor injection, everything's there. You can just start using it. With field injection, when the object is created, you then have to pass it to a component, which is a second step. If you don't do that, this field's going to remain null, and you're not going to be able to use your object. So you create it in sort of a halfway state. So some of you might be asking, okay, so there's two steps. You prefer constructor injection over field injection. Then why does field injection exist? And what is the purpose for it? And so field injection comes up a lot on Android because you don't always control the creation of your object. So a lot of you probably have your application set up where fragments or activities are not created by you. The framework creates them. And so you have to do field injection. And then this is the second step. There's more code that's actually involved with this, but this is just, I wanted to show the second step of field injection. You have to actually pass the cache to a component for it to actually inject it. We'll cover components a little bit later if that's a little fuzzy on what that's actually doing. And so, going back to components, I think this is always conceptually when people start off, they're like, what are components? And I don't really understand what it's for. When do I need to create one? And I think oftentimes people create components when we're working on chat that we don't actually need. And so the biggest way that I can try to simplify what a component is you can think of it like a giant object that provides all of the factories or providers for all of the objects you want to inject. So it's basically like a big container. It has all the factories and instructions. It also does a second thing, which is it will retain, optionally, it will retain objects for you. So that image cache we want, our component would be responsible here for actually retaining it. You'll see also that the component here itself is an interface. And so that's another important part, is that Dagger is actually going to implement this interface. And so you might be wondering, okay, well, how is it going to implement methods and stuff for me if I write methods on here? Well, Dagger is going to look at the return types of the methods, and it's going to use that to figure out what it needs to provide for you. So if we threw our image cache as a method on this interface, it would try to figure out, okay, I need to actually provide image cache somewhere. Also, another important thing is these components don't exist in the ether. If you create a component and you don't store it anywhere, it's useless. You just threw your cache away. So you have to actually retain it somewhere. So in Android, it's very common to attach these to things like your application or your activity or a fragment. And the reason for that is that if you have a context, you can always get the fragment, you can always get access to your activity, you can always get access to the application. So it's a really great place to control things. And the application works great if you have something like a singleton, because there's only one instance of your application for the entire instance, right? So that's where you would put your image cache if you had something like that. You also notice at the top, there's this parameter for modules. We'll talk about modules next. This is usually an array. I just put one object in here. So with your component, you have to pass it a list of modules. And modules themselves are basically used to tell Dagger when you're trying to inject something that Dagger itself is not going to ever be able to figure out how to do. So that interface we talked about earlier, that network API, you can't construct an interface. So you have to tell Dagger, well, once I ask for the network API, what do I need to return for you instead? So in this case, I have an implementation of the network API, and I tell Dagger, every time I ask for this network API, give me this implementation. So you can think of modules sort of like a recipe book, and you have all the different recipes for how to create things and find things that it might look for. Also, if you were looking for like resources, you don't create resources, the framework does. So you would want to tell Dagger how to look up resources, maybe using a context or something like that. You can also imagine that maybe in tests, we probably don't want to use the real implementation of our network API. We probably don't want to actually make those real network requests, but we still want to test our image cache. We still want to make sure things work. So modules also let us swap out different dependencies. We can swap out the module to basically get something else behind the hood without anything else in our app knowing about it. And so it's very common at Google. This is actually how we build features. When we design new features, we'll usually make like a no-op implementation, and then we'll make a real implementation. And when the feature's in development, everybody gets the no-op version. It doesn't do anything. And when it's actually gone through QA and it's ready to go up, we'll swap it out. The last thing we're going to sort of cover with the foundation of Dagger is scopes. So scopes come up a lot when it comes to controlling the life cycle of things. So far, we've sort of talked about like creating things. We talked about components, which actually have the factories for providing everything. We've talked about modules, which are the instructions for creating things. What about retaining things? That's what scopes actually help us do. So you get one scope kind of for free out of the box from the Java X package, which is singleton. But singleton isn't like it doesn't just like magically work. You have to actually apply it to your component. So when you define a component, you have to actually put the scope on top of the component that you want to use. So you would put singleton on top of it. And then when you want to inject a class, you want to make sure there's only one instance of it. You also have to put it on the class. Otherwise, Dagger won't do that. This is sort of how it figures out like where to store things, like what component do they go to. If we had a separate scope, it would know like, okay, image cache isn't supposed to be retained there. And it tries to find one that matches with it. You can also do stuff here to sort of prevent memory leaks or maybe using things outside of the wrong scope. Maybe you have a feature that's designed for the activity and someone tries to inject it in like a service for whatever reason. The scope would actually say like, oh, hey, no, you can't do this. This is for the activity. You can also create your own scopes. The singleton one's created for you, but if we wanted to create our own like activity scoped feature, you would just use the scope annotation from Dagger, create your own annotation, and then do the same thing as before. You would just apply it to the component and apply it to the class, and then that would change where it was at. So now every time we would have a new activity or activity gets recreated, we would get a new image cache. And so we've talked a lot here so far about Dagger. And so what does Hilt like actually get into this? And so Hilt is a library that sits on top of Dagger. And Dagger is pretty open-ended. It's not designed for just Android. You can use it on the back end and stuff like that. So Hilt is actually designed for Android, and it's designed to be very opinionated about how Android works. And so Hilt, we talked a little bit about this earlier, but I want to dive into it a little bit more. Hilt really makes your life easier by simplifying the overall setup of injecting those like field injected classes. We talked about activities and fragments needing field injection. Well, there's some extra work you had to do there, and Hilt makes it so that you don't have to write any of that. It makes it all easy and sets it up pretty well for you using bytecode manipulation. It also provides a standardized set of components. So we talked about components and all that before. If you use Hilt out of the box, you get a set of components so that you don't have to write your own until you get to a point that those components are no longer, like you need more features, you can do that later on. So Hilt lets you defer the initial cost of trying to use Dagger, rather than having to go in and be a complete expert on Dagger, set up your component hierarchy and wire everything up. And just 2 lines of code, you can throw in some stuff for Hilt, and you can just start injecting things and get going. And the last thing that is pretty critical that I think sometimes gets overlooked is it lets you use dependency injection in your tests. So this has come up a lot at Google. We try to use real implementations as much as possible in our tests where we can. And we've actually caught a number of bugs that we wouldn't have been able to catch if we were using fakes or mocks. We weren't setting things up how they normally are. We usually have this thing with things like our executors. So we'll actually run our real executor thread pool in tests. So everything's multi-threaded, and we can actually catch a lot of race conditions and things that happen. Some tests people will write where they'll try to use just single-threaded because they're in the test. They'll try to pass the same, like just a single thread pool. And there's a lot of bugs that get hidden that way. So dependency injection makes that part easier for us. To use Hilt, these are the 3 common annotations that you'll end up using. So you'll see at Android entry point, install in, and Hilt Android test. We'll go ahead and start with Android entry point. And so let's say that you set up a fragment to inject your image cache. You do something like this. It's a fragment, so you have to do property injection like we talked earlier. And you might think that, hey, this should just work, and like my image cache should be there. And then you run your app, and it's constantly null, and you're trying to figure out why. And it's because you didn't actually set this up for dependency injection. So you have to write a little bit more code to actually get that set up. And this isn't all-encompassing. You'd actually have to write similar code for your activity and similar code for your application. So I've written 2 things here. I've had to go in and define the component, and I've had to go in and modify our unattach. So this is the point that we know the object's been created, and we can set up injection. If you use Hilt, you actually don't have to do any of this. You just have to annotate the fragment with that Android entry point. And what Hilt will do is it will actually write a base class that looks kind of like this, and it will change your fragment to inherit from it. This makes it a little bit easier so that you literally just have to do 1 line of code, and then everything should work as you expect. This may bring up another question you may have. If we go back to our component slide from before, you remember these modules that we talked about? Well, if Hilt's generating the component code for me, how do I pass modules to it? So the way that you actually go in and do that is through the use of @installin. So Hilt kind of reverses things here a little bit. Normally in Dagger, you create a component and then you provide it a list of modules that you want to use. With Hilt, it's the reverse. Your modules say what components they want to be installed in. This is actually really useful for us when we're trying to compile things out, because we don't have to modify the production component. We just don't include the build rule, or we don't include the library in the build, which means the module isn't there, which means it doesn't end up in the component. So it's a little simpler. Hilt also will even help you out here a little bit if you forget to use the @installin annotation. Hilt will warn you at compile time and say like, hey, you probably forgot this. You can get rid of that with a migration annotation they have for @disable installin if you're already using Dagger today. And so you might wonder, where does this singleton component come from? And so this actually comes from a common set of components that Dagger actually provides out of the box. So this is a quick list of them. You don't have to create or manage these, and Hilt's actually smart enough that when you extend from a fragment or you extend from an activity, it will actually know the right component to use for you. The other benefit here is you can also play with these a little bit. This is a little bit more advanced, but you can actually add to the ends of these. You can't modify, you can't insert things in between, but on like the view component at the bottom, you can add your own custom component too, and Hilt has the ability to pick that up through the use of custom component annotation. I'm not going to get into that too much if people are interested about that. It's a little bit, I think, too much to try to cover. But the major benefit here is that you don't have to have the mental load of defining all these components when you get started. If you have an existing application and you want to use Dagger, you're probably going to have to create all these on your own. So it's really nice to have Hilt do this out of the box. That's also set up, these components are also set up as a hierarchy. So things are shared from top to bottom. So anything that you install in the singleton component can be accessed anywhere in the application through dependency injection. Things that you install in like the fragment component, for instance, can only be accessed in the fragment component and the view with fragment component. You can't access them in the activity or chain component. And if you're wondering a little bit about like what's the activity or chain component, that's basically for rotation. If you have an object that you want to actually still be the same object when you rotate, you would install it there. And then if you're not using fragments, you can start using just the view component, if that's something that your application isn't using. And sort of the last thing that we're going to cover today is around testing. To get tests set up with Hilt, it's actually pretty easy to just add the annotation to your test. So if we were to use our image cache here, you can just throw the annotation on top, make sure that you're using the rule, and now everything will just get injected for you. And so this makes sure that you don't have to set up your image cache. This actually makes large-scale refactors for us really easy. Because previously in our tests, we would manually create the object in the test. We use dependency injection in production, but then in tests we would manually create the object, or we'd have a util that would do it. And so if you went and added something new to that image cache, like a new parameter to the constructor, you'd have to go and update everybody's test that uses the image cache, and that was always kind of a pain. Now you don't have to do that. Dependency injection will just provide it. And so as long as you don't change the contract of how the image cache works, you don't have to update the other tests, which takes the mental load off reviewers and stuff like that. And with that, that's pretty much it. I wanted to set up some time. Oh, wait, no, I forgot something. This is also something else that you would have to include as well. So you'd have to include the test module in there as well. But I wanted to set up some time too. I think we got lots of time for questions if anybody has any.
Thank you. I have a question. What about customizing hierarchy? So for example, I have fragment and I have sub-fragments. Like for example, fragment is wizard fragment and sub-fragments is a step of this wizard. Mm-hmm. So I need a component to have life cycle of step and another fragment component with life cycle of wizard itself. So can I build custom hierarchy in Hilt?
So just so I understand, so the idea is that you have some child fragments and you want to interact between. Yeah, so Hilt does let you set up custom components. I think it's not, just to be honest, it's not fully fleshed out. It's a little, there's some rough edges with it, but you can create custom components. At Google, we actually do have our own set of custom components we reuse across apps. We can't open source them because they're very specific to Google, but that is something that you can do. So you could create a child fragment component or something like that.
Okay, thank you.
Hi, can you, if you have an application with multiple modules and you are using, let's say in the app module Hilt, can you use as well Hilt in the other modules, or you would need just to use plain Dagger or something?
So I'm sorry, so if you're using different, you mean application modules? Nothing with Dagger?
Yeah. Let's say that you have different Gradle modules to separate your application. You have an app module, let's say a registration module for a registration flow or something like that. Can you use Hilt in the registration module as well? Because I know that you can in the app module, but I don't know if you can as well in the registration module.
Yeah, so one of the neat parts about Hilt is that you actually can have those modules. You can have those modules used across multiple libraries, and the application when it gets built sort of is the one that looks through everything that's being included, and it will make sure that everything's provided. So when the module or library gets built, it doesn't have to be fully you don't have to have everything satisfied. Yeah.
Thank you.
So one question. So what happens, for example, if you have a submodules architectures with factories? So this is could be replaced with Hilt, with the same annotation. We need to do something special for this type of cases.
You mean, sorry, so you mean if you have factories and you want to switch over to dependency injection, or?
Yeah, if you have submodules and submodules for each fragment or whatever, we have factories. So we are using submodule architectures to move this type of submodules, right? That is of Dagger. How you can replace it, this one, with Hilt? Exists any possibility to inject this one directly, or you need to do something special?
So if If I understand correctly, so we use auto factory a lot at Google. So we have some things that we can't provide in the constructor. Maybe it's like a view or something. And so auto factory does actually does integrate with Dagger. It does generate everything that you want to use. So if you're using something like auto factory, you can switch over to Dagger and it should just work out of the box. But yeah, if you're using existing factories, you could migrate one by one. Dagger would actually like sort of get rid of the need to have factories. If you don't scope something, every time you inject it, you'll get a new instance. And so Dagger sort of has a concept of factories. It's called provider. So you can do provider and then your class type. And when you inject that, every time you call get on it, you'll get a new instance if it's not scoped. And so you can use that as sort of like a factory.
Okay, so and then if you, for example, you have a factory for a bind instance for pass any parameters or something to share between fragments, you can use it as well, right?
You need to use auto factory for that. So
Okay.
the provider thing that Dagger provides expects that everything can be provided. Nothing like there's nothing that's variable between them. But if you use auto factory, then you can do that. Yeah.
Okay, cool. Thank you.
Hello. Yeah, is there support for dynamic feature modules?
I'm sorry.
Support for dynamic feature modules. Is there?
So I'm not sure. I don't know what dynamic features would be like things that load later on, or
Yeah, the one from the Play Store.
yeah. So that's going to be hard because everything has to be there at compile time, right? And so if something is added later on, it might not work. I will say so. I haven't used that feature myself. I know if you do things with like binds optional of, where you create an optional and you load things later on, it may suddenly see that the optional is provided, and then it may actually work, but I can't guarantee that will work. But you'd probably want to use bind optionals of, treat it as an optional or nullable if you're in Kotlin, and then handle that basically as the code being there or not, or the feature being there or not.
Okay, thank you. Another one. If I have a Kotlin-only module, not an Android module, can I scope things to, I don't know, activity or fragments scopes? Or
So what is this module?
a Kotlin pure module?
A pure module?
Yeah, not an Android one.
It should, if it's still using Dagger, the module is designed for that. It should allow you to scope it or install it wherever you want.
All right.
I haven't tested that, but I think so.
Cool, thank you.
Hi, we have an app, and if you launch it, you can press the splash screen 5 times, and then we switch to demo mode. And we want to switch to a demo dependency graph instead of the normal graph. We didn't figure out how to do that without relaunching the whole app. Is there something?
Yeah, so what you're bringing up, I know what you're talking about. So this is actually, we used to use the Dagger Android like integration for chat. And one of the benefits of that was like each one of our activities or fragments got their own unique component. We could install like different features that way. With Hilt, all of the components for all of your fragments, it's the same component. So you can't selectively like include things differently. You can try to look at like intent arguments or things like that when the activity's restarted or the fragment's recreated that sort of provide something different. So you could have like an implementation that's like your demo mode, and then, you know, if demo mode's disabled, you would like return something else, whatever the different implementation is. And you'd have to do that in like a module through provide somewhere.
So we're currently working on an app, and the backend and frontend are kind of working together at the same time. And sometimes backend is a little bit slow, which means that we have to mock certain things. And the way that we do that is through app flavors. It's really easy to make a dev, a prod, and an ack, and then we have a local one. And we were wondering, or we have tried a lot of things to kind of inject a different kind of model or object in the local environment than in the dev, et cetera, et cetera. Mm-hmm. Is there a way we can like override a certain install, or so they can live together, and like, is that possible in some way?
Yeah, so this is the one thing that is a little bit different. So at Google, we don't use Gradle internally. We use a different build system, and every package that we create is its own library. And so because of that, we just include modules in the packages, and that's how we selectively push things out. If you set something up for those different flavors as like a different library or a different module where the code's isolated, and then include the modules in there, then you would be able to swap things out. But I know that's more set up with Gradle. Yeah.
Yeah, the issue is that because we have 3 modules that actually, like 3 flavors that use this common network API, and then the local one needs to have a different one. So then we otherwise have to set up the module 3 times, and then the local one. So you get a lot of duplicate code, and it just gets worse and worse from there. So maybe if there was like a way to override a certain module in a specific flavor.
I know for tests, they let Google 3 code work. For us, they don't trust us with that ability to do that. Yeah, I think that's probably something that, it's probably going to be difficult on Gradle. And I would definitely actually try to file like feedback on that, because I think that's actually important that you can like configure things a little bit easier depending on what you need, rather than having to like throw stuff everywhere. And that might be an artifact that Hilt was actually internally a Google like internal library for the longest time. And then we were like, we should probably just open source this. And then some of the things that we do are different from what everybody else does. And that might be a blind spot that we're just not aware of.
Cool.
Awesome. Thanks, everyone.